Connected in 3D, Real-Time Solutions and Digital Twins podcast with your host, Ashley Crowder.
Hi, I'm Ashley Crowder. Welcome to Connected in 3D, Real-Time Solutions and Digital Twins. I'm your host here talking about different use cases and sharing knowledge about 3D to help businesses scale with digital twins. And I am so excited today to be here with Aaron Luk, Director Product Management of Omniverse at NVIDIA, and he leads OpenUSD at NVIDIA. So Aaron, thanks so much for joining us.
Hi, Ashley. Good to see you again. Thanks for having me.
Yeah. So it's funny. I think I met you through Kronos, which is the nonprofit for GLB file format, and then OpenUSD is the other file format that's really becoming the standard as well. So why don't we start by explaining, what is OpenUSD and what sets it apart from other 3D frameworks and formats?
Sure. OpenUSD is a technology that was really decades of evolution at Pixar Animation Studios, where I used to work, in terms of really stitching lots of different data together into a coherent whole, in Pixar's case for movie making. But over the years, they abstracted so much of just how 3D data is described that turned out to be really useful for other industries. The original intent, when it was open sourced in 2016, I believe, was really just kind of seeing how useful it is to other movie studios and things like that. So like while I was still there, we had a lot of meetings with other movie studios, and just saw that, we're solving a lot of the same problems, and we've even places who had solved similar problems kind of did so with kind of like multiple file formats and things like that. Right. Distinguishing thing about OpenUSD is that while it does manifest as a core set of file formats, it's totally abstracted from file formats in general. So you can feed it from databases, you could feed it from CAD sources and all these kind of things. So all those sort of principles of assembling heterogeneous data for movies, such that our artists of different disciplines can work on the same thing together, applies to real world sort of industrial engineers, mechanical engineers, electrical engineers, all kind of working on the same facility together virtually, just like movie artists do in production.
Right. And so high level OpenUSD is for a lot more complex projects, multiple people being able to simultaneously work on an interactive 3D item, whereas GLB is kind of more that efficient file format for publishing, versus and disagree with me if I'm getting
That's
it wrong.
one way of thinking about it. I really don't see them as like competitors. Like I think they're both like. Similarly, like GLB is also a format, but it's a formulation of GLTF, right? And so similarly, what USD and GLTF and GLB have in common are these data models, right? In terms of how to describe the world and things like that. And so, yes, you could think of GLB as a distillation of those data models optimized for device delivery and things like that. But like, I don't think that's in competition with like the general problem of describing the world. Like actually, some of my favorite times of the year are like at SIGGRAPH, when in that sort of GLTF. I forget what it's called, a forum, right? Like and we all kind of like I always enjoy sort of representing the OpenUSD side together there, but it's a lot of the same challenges are there. A lot of them, the challenges between them, actually, the ones that interested me the most are actually the non-technical ones. Like, I'm sure it's going to come up again in the forum at SIGGRAPH this year. It's like, okay, what's next with profiles for GLTF? And that's an issue that we're also discussing now in USD as well. There's a proposal for it from Apple, right? And so this is not. And this is something where it's great for both USD and GLTF folks to compare notes together, because we're in a similar place where it's like we all recognize there's a need for profiles because both GLTF and USD are so vast that like certain domains might only care about certain feature sets of USD and certain feature sets of GLTF and things like that. We all know that we need that, but we're all still in this place where it's like, oh, if we start drawing these boxes and profiles, that's going to kind of like limit what you like. And both technologies are evolving so fast that it's like, okay, like when is the right time to sort of like, put up these little like containers of information and stuff. So I think in that sense, like the USD and GLTF communities are really, really, really like in synergy in sort of discussing those kind of issues. On the technological stuff, right, it's just the same as any other sort of like 3D formulation. Is like, how do we map data models to each other, because we want data to interoperate. Like no one, as far as I could tell, on the USD or GLTF side is interested in fragmenting the content ecosystem, right? We all know, especially for digital twins, that all the content kind of needs to speak the same data model, right? And as far as I could tell, like USD and GLTF, like they're quite aligned on most of the data models, and the ones that are not are like materials. There's a lot of great momentum in materials right now around in the USD we're with OpenPBR, right, and Material X, which GLTF is also sort of like incorporating and figuring out how to harmonize GLTF PBR with OpenPBR and so on and so forth. But at the end of the day, it's like light bouncing around the world, right? So it's like we all observe it, like and we can all agree on how to represent that.
Right. Yeah. Well, and I fully agree. I think they are compatible file formats. I think we're all pushing for 3D interoperability, so it's easy to represent the real world in 3D on any computer device. And at Ventana, we're working with both groups because we can ingest USD and then convert it to a GLB, but we're still looking, because as these file formats continue to evolve, there's new things in USD that don't exist in GLB yet. So do we delete it? Do we convert it? But
Right.
We're super excited about all the work the two groups are doing together to be able to make it easy to go back and forth. But going back to just kind of like this landscape of real-time 3D and digital twins, how are you seeing OpenUSD like changing the landscape for industries and immersive technologies? Like, how is OpenUSD like pushing the industry forward?
Yeah, so we're even in the Pixar days, we were using USD for like virtual location scouting, right? So in VR, AR, XR, right? Directors could look at all these locations that don't exist in the real world and sort of play around with camera angles and things like that to map out possibilities for their movies, right? And so it's not a new concept. Even the industrial world, like people have been doing stuff like that. Now, what USD adds to the mix is like, oh, there's all sorts of other data that maybe wasn't possible to bring into that world before. That now that it speaks USD, you have that additional context. So you can imagine someone like in a digital twin of an operational factory, right? And they not only get all the geometry, but they also can kind of see some sort of visualization of the IoT data that's flowing through it as well. So you can imagine all sorts of interesting, spatial computing workflows along with that.
Definitely. Yeah. So we talk a lot with our manufacturing clients about real-time monitoring of equipment, real-time like maintenance analysis, and being able to do that with digital twins is huge. Our client Aztec is really forward thinking in that space and doing a lot. And that kind of leads me, I know we're skipping around, but what are some other, real world use cases and different places you've seen adoption of USD?
So there's quite a lot of adoption in different industries. I could tell you one use case that sort of brings a lot of them together, where one of NVIDIA's partners, Wistron, actually did build out, or they built a new facility in Omniverse with USD, right? And they sort of gutted an existing building and then built the facility for real in that building. And now it's an operational digital twin of that facility that has real products being manufactured, and they did it in a matter of months, like from digital to real to operational.
Wow.
Yeah.
That's amazing. And that, leads me to NVIDIA Omniverse. If you want to explain a little bit more about what that is for maybe listeners who don't know, and how OpenUSD is a huge part of that.
Yeah, so Omniverse is a platform at NVIDIA built on top of OpenUSD. It's an operating system for physical AI. So for those who have seen Jensen's keynotes at CES and other places, he talks about these three computers that are needed for physical AI and particularly for robotics, right? One is the robot brain itself. One is the AI in which the robots are being trained, and the one in which Omniverse serves is the virtual worlds, the simulated worlds in which the robot learns, right? And so you need kind of OpenUSD to be able to describe all not just the 3D, but all the data that like is spatially flowing through the 3D. Maybe there's not there's like stuff that's not visible to the human eye, right? So you got to do all these renders, not just in photorealistic ways, but radar realistic ways, right? So you get sensor realistic ways, right? So Omniverse has particularly an offering called Sensor RTX, right, in which you can produce tons of scenarios in which you can simulate robots and how they perceive the world to train them in that.
Wow, that's amazing. And I know what's great about Omniverse too, you guys really went about it of it's more pixel streaming, like you have no limit on file size. You want, all the data there. And we have a client I know who's been able to bring in full simulation models from Altair, ANSYS, you name it, bring in that work and then visualize it and build out the full manufacturing plant. So you can say, okay, if this plant ran at 100% capacity for 3 years, what's going to break down first? Which is another really great example of how I've seen people use Omniverse.
Right. Yeah, exactly. And it gets to interesting places. You asked about real-time 3D, which is definitely important for the interactive experience and how humans interact with virtual worlds. But there's this other axis of performance that is kind of like not the same as real-time. And in some cases, it's beyond real-time, and sometimes not. And that's just like pure throughput of how much imagery you can produce to train these robots, right? Because the more that the robot perceives, the higher confidence you have in how it's going to react in real world scenarios.
Yeah, that I'm very excited about that. I'm assuming all the Waymos and driverless cars are doing that versus just practicing on the railroad. So
Yeah, that's right. Yeah. Especially, I mean, there's all sorts of scenarios with railroads that you would never want to actually put into motion in the real world, right?
Yeah, that's great. And you mentioned, Jensen announced a lot of that at CES. There were, several advancements showcased around this vision and this three pillars. I mean, any surprises that particularly excite you about how this is, pushing industry forward?
Yeah, sure. I'll start with one that is sort of less of a surprise and more on the trend that we were going in general, which was the announcement of Mega, right? So that's like being able to train fleets of robots at scale in industrial facilities. So it kind of, it's a big sort of the next evolution of the sensor RTX effort to really do this at scale, and that's why the throughput I mentioned is so important. The second that is more surprising is Cosmos, right? In terms of this world foundation model in which you can do generative video that is actually, physically accurate, that obeys the laws of physics, right? So a typical sort of feedback loop is that you kind of like generate sensor inputs and outputs in Omniverse using the 3D data that you've put in there, right? And then you can create variations. You can vary the scenario with Cosmos then to vary different conditions of your scene and things like that. And boom, you've now like exponentiated the amount of data that the robot is able to learn from. And then from that, right, you can improve what the behaviors inside of Omniverse as well, and then kind of you get this nice sort of loop of information between Omniverse and Cosmos that results in like just an optimally trained robot.
Wow. Yeah, it's really cool. Again, we've got a shared client, so I'm not going to say what they're doing, but it's amazing what they've done between us. And it's like they're running these scenarios within Omniverse, and then they've been able to upload a lot of that 3D content to Ventana to then present and share in various capacities. And anyways, I'll be excited when they can talk more about it.
Yeah, cool. Sounds great.
Yeah. And so kind of, all this is really possible with OpenUSD. So from, going back to the file format and from the technical standpoint, what are some of those unique advantages that OpenUSD offers for digital twins, like to make this all feasible?
Right. Yeah. So the big one is the composition engine, right? And that is there's an algorithm behind it, LIVRPs, which stands for local inheritance variance references payloads and specialized. Oh, actually, no, there's a relocates in there now as well. So it's LIVRPs. So there's an actual E for relocates in there now. And so this is an algorithm that we're actually writing a specification for now in the Alliance for OpenUSD in the core specification working group where I'm serving as chair. Right. So that's the big sort of innovation of USD is that it has this algorithm for how you layer different types of data together, right? And at this level, we're not talking about 3D. We're talking about just raw documents with key value pairs, right? But some of those key value pairs are special, like there's a references arc and there's a payloads arc and so on and so forth. But everything else is just kind of like I have an object and it has these attributes and relationships on it. Now, that object might happen to be a sphere or a mesh or something like that, but at the composition level, it doesn't care, right? So that is a super powerful way in which you can bring CAD data together with robotics data, right? And then layer IoT data on top, right? And it's the same concept as how in a movie, an animator, a rigger, a lighter, effects artists, they all kind of work on the same thing together, right? Same for a robot, where the manufacturer and the roboticists, they all kind of work off of the same data.
Yeah.
So that composition is sort of the biggest. There are other things as well, but I think that's the biggest takeaway for folks to learn about USD is that it's this way of stitching multiple pieces of data together.
Yeah, definitely into a single unit that you can deploy across these different platforms.
Yeah.
And so what are some of the biggest challenges the OpenUSD group is trying to tackle in the next few years?
And so there's an ongoing kind of like, the faster you move in terms of adding new features to USD, and by features, I mean more like data models and behaviors, right? So it's not like we're going to change the composition or anything, but OpenUSD does support custom schemas, right? And those schemas are ways in which you can bring in existing data models like CAD or URDF for robotics, right? And then they can be represented in USD. They don't have to be written out to USD, right? But USD does need a schema to be like, oh yes, I understand what that piece of geometry means, and I understand what that robotics information means, right? And then those have certain behaviors as well too. So one of the biggest challenges is that right now USD is purely declarative, right? Which is good for assembling data together, but like what if you need computed behaviors, dynamic behaviors, right? The kind of things that you see in like game engines or even at Pixar itself, where you can build character rigs on top of USD to pose characters and have effects and things like that, right? So Pixar has announced an initiative called OpenExec, in which they are going to take the execution system from Presto and open source it, as part of the OpenUSD stack, right? And I think there's a lot of potential there. Certainly, like it's going to be useful for the media and entertainment folks who are already invested in USD to be able to represent their own rigs and things like that. But for robotics is where I'm really interested in terms of how we have a lot of folks at NVIDIA who like me who worked on the Presto execution system who are now learning robotics as well, and so I'm really excited about figuring out, for robotics behaviors, how do we map those into the concepts that I already know from how the Presto execution system works. I think it's going to be exciting. I think it's totally doable because like USD, the execution system is very sort of foundational, low level, and doesn't really make a ton of assumptions about what you're trying to do with the data. So I think that's probably the biggest one that's on the frontier right now, and it's certainly been in discussion for a while. But like Pixar's done some great presentations on it over the past couple of months, and it's and that's something from the NVIDIA robotics and the Omniverse side that I'm looking forward to sort of lofting up sort of our use cases and working with folks on how we kind of make them a standard too.
Definitely. Yeah. Because I can imagine, I'm imagining Amazon warehouse with the robots that go pick the packages, and how do you model that within Omniverse using OpenUSD with that? And at least I think that is at least one use case where that would really, really help.
Yeah, exactly.
Very cool. And we've talked about, so like OpenUSD is, forum you can join. So if you want to contribute, it's an open group, which is great. And it's a really great community. And I believe, we already talked about, you're working with the Kronos group, another open group pushing GLB standards. And then there's also like the Metaverse forum.
That's right. The Metaverse Standards Forum. Yeah.
Yeah. And how do you see OpenUSD shaping the future of the metaverse, and how it can be the foundational building blocks for creating interoperable virtual worlds?
Yeah, certainly it's already playing a big role in what we're calling the industrial metaverse, right? As industrial digital twins, operational digital twins, from greenfield to just like the Wishron case, building something virtually and then building it for real, but then using USD and Omniverse to then operate and monitor the real facility. So that's the big one. But the metaverse, it's certainly, it's still kind of like vast, right? My focus is on that industrial side of things, but certainly there are other members of AOUSD, right, like Meta themselves, right, who have other formulations that are non-industrial, right, that are more kind of like, how do we can all be avatars in a virtual world together, right, things like that. And certainly USD is part of that workflow now too, and in similar ways that it is used in other media and entertainment for letting lots of artists collaborate together to make that world together. So it's still going to continue to play a role there. That's not my focus, but it's certainly a really good fit for that, because in a way that's kind of what it was always designed for, to even within Pixar. That's actually another cool story to tell too, where even when I was at Pixar, we weren't using the term digital twins, but we were effectively like designing like theme park experiences in with USD in Presto, things like that. So like the Finding Nemo ride and the Ratatouille ride, they were kind of done with if not USD, then like the predecessors of USD, using those same principles and things. So we weren't calling it digital twins at the time, but even within Pixar, there were these industrial use cases for this technology.
Yeah, that's amazing. I'd love to see the Finding Nemo world.
Yeah.
Cool. And so for developers and organizations interested in OpenUSD, how can they get involved, and what resources does NVIDIA offer for those looking to integrate USD into their ecosystems?
Yeah, certainly for newcomers, I really recommend NVIDIA's Deep Learning Institute, where we have a Learn OpenUSD curriculum that we've been building out. We debuted it at SIGGRAPH last year with some of the basic foundational models. We have some more applied concepts that were added, I think, just last month around the time of CES as well. But this is going to a continuing thing that we're always adding more modules for, and that we're looking into building a certification program around as well.
Oh, that's awesome. Yeah. I'm going to check that out to brush up on my
yeah.
That's amazing. And what does the future hold? I mean, we talked a little bit about, some of the things that OpenUSD is working on to enable the robotics training, but especially with NVIDIA Omniverse, how do you envision it expanding the possibilities of real-time 3D, other industry applications that you see that's, helping to solve core problems for?
Yeah, I think scale is probably be the biggest frontier, right? We're always going to be scaling out to more. With robotics, it's more like this. I want to take this year to zero in on what it means for robotics to be a first-class citizen in USD, right? So, like I said, kind of taking the CAD data, then your RDF data, and other sort of robotics information, and formalizing schemas around them. At least as a proof point of like, oh, okay, there's lots of different stakeholders in the robotics ecosystem. If they all speak USD, we can get lots of great benefits like co-simulation, right? So certainly for an individual robot, but certainly for fleets of robots in these settings, right? They're not going to be all using the same physics backend to simulate, locomotion and gripping and all these things, right? So you're going to want something like USD to sort of cohere that all together, all right, for your digital twin and for your perceptual AI. And so I think this is a great year to sort of like, now that we've sort of proved what's possible, to sort of start doing the work of tying it all together into something that will feed into a standard.
Yeah, to be easy. So if I have a robot from Waymo and one from Bosch or whatever, the data makes sense together.
Yeah, exactly. Yeah.
Very cool. Well, awesome. Well, Aaron, thank you so much for joining. This was extremely informative. I'm really excited about all the possibilities with Omniverse and the industrial metaverse that you guys are enabling. Where can people reach out if they've got questions or want to kind of get involved?
Yeah, so there are both AOUSD forums at forums.aousd.org. There are also Omniverse forums as well, and like you mentioned, folks can join AOUSD like either as members or as contributors, and there's always great dialogues going on there. I will definitely be at GTC this year in San Jose, and be talking more about sort of like what are the next steps for USD from both the NVIDIA front, but also on the the pure standardization front in AOUSD, and those kind of twin roadmaps that balance like innovation and standardization, because we really need both, right? And it's really it's exciting and also scary straddling those worlds. I'm sure you feel that too, right? It's like, oh, we got to move fast, but we need everyone on the same page too, right? So so a lot, like, definitely, like, there's going to be a lot of great kind of in-person interactions, but you can also attend GTC virtually as well. But I think that's where a lot of these kind of conversations really start to resolve in terms of the innovation and standardization pillars.
Awesome. Well, I will see you at GTC because I'll be there as well. And thank you again so much for joining.
All right. Thank you, Ashley.